Okay, so today we're just going to go over a few things that have to do with the periodic table to make sure that you guys have everything down. So when you're looking at your periodic table, your one big number up here tells you that this is the atomic number, and this tells you the number of protons. Now, hopefully you remember me kind of overemphasizing this last week, that is the most important number because that is what determines which element it is. You can change the number of electrons, you can change the number of neutrons, but you cannot change the number of protons and still have the same element. So that is really, really important here. This Be, again, super important. This is our chemical symbol. And this is the only time in grade 9 where spelling is really going to count. Sorry, the only time in grade 9 science that spelling is really going to count. Having it be online, you have the option of like spell checking a lot of things. But part of the problem with the computer is that it's going to want to change your writing of elements so that you don't necessarily have a capital always first, and they don't like that it's not a real name. So you're going to need to be very careful about this. When you write a chemical symbol, the first letter is always capital and any letters after are always lowercase. It's very important. So be really, really careful about that, especially when doing Google Forms. And I know that some of you are going to struggle because the computer is going to change it on you. So just try really hard to get that through. This is our chemical name, the beryllium. I love writing for people because I clearly just write wrong. Then down here, this is our atomic mass. Now our atomic mass, this is the average of all isotopes. And why do you care about that? The only reason why you care is that's why you get this decimal. The decimal is because it's including all of the possible isotopes that are available. So that's why you have that number there. Now, your periodic table also has a few other things. It has this. This is the ion, or the ionic form of your beryllium. And this is the ionic name. Now, the ionic name is exactly the same as the chemical name for metals. That is really important. So I'm going to take another thing here and say in the corner, ionic and chemical names are the same for metals. Okay, so we're going to just do the same exact thing, but looking at a non-metal because there's, well, overall there's not huge differences, but there's like a couple little things. So let's do, this is our number of protons. I was trying to write it as this, P plus, because that's proton symbol. And this is our atomic number, same as above. This is our atomic, our chemical symbol. I'm so excited. This is our chemical name. And this is our atomic mass. Now, it's still the atomic mass, even though the decimal places are 0, because it's still taking into account those average of all isotopes. Then you have the ionic form. And on both of our ionic forms, it tells you the charge. So up here as well. then this is our ionic name. Now, you will notice, and this again is super important, that the chemical and ionic names, they are different for non-metals. The ionic name will always ends in IDE. And I'm going to put quotations around always, because what you're going to learn in chemistry is everything I teach you for grade 9 is true in grade 9. And then when you go to grade 10, we learn something a little bit more, and then there's all these exceptions. And when you go to grade 11, there's more exceptions. And so by the time you get to university, you're only learning the exceptions. There's no more rules anymore. But all of the basic rules we teach you this year in grade 9, you need to know to be able to understand the exceptions. So I'm not lying to you. I'm not teaching you anything wrong. I'm just teaching you what you need to know for this level, because there are many, many, many exceptions to come. And we will get into some of them even this year. So this is your basic though. How many protons? The atomic mass. Now, let's just go back to the atomic mass for a second. So the atomic mass is the average of all isotopes, which means it's protons plus neutrons. So if you wanted to know the number of neutrons for beryllium, you would simply take 9 minus 4, because this is your atomic mass minus your atomic number, and you round this atomic mass to the closest number, and you would get 5 neutrons here. Over here, you take your atomic mass, which already is rounded to 16 because there's no other numbers, minus your 8 protons would give us 8 neutrons for that one. So that's how you'd find those two. Okay, I think that's all I want to make sure that you guys know for this video. And then again, we'll just keep on going.